My name is Reese Hodges, and my final year project was to design an eye-controlled wheelchair with the help of my group members Andy Ganem and Stephanie Adamovskis. For this project, we were supervised by Dr. Michelle Dunn. The inspiration for this project came from our initial research into current assistive technology, where we discovered that a whopping 1 in 5 Australians suffer from a functional disability. Oftentimes, this disability was a physical or motor impairment, which made it difficult or impossible for an individual to perform basic everyday tasks, such as moving independently. Common examples include cerebral palsy or motor neuron disease. What was even more alarming was that numerous research articles repeatedly raised concerns that a lack of available assistive technology was a common issue for both motor impaired individuals and their family members or caregivers trying to look after them. This has led to stress, frustration, and a lower self-esteem for both the motor impaired and their caregivers, emphasizing the need for change. Our group decided that the most impactful form of change we could provide was to offer a form of independent navigation to motor impaired individuals. The primary aim of the design would be to improve the quality of life for motor impaired individuals while increasing their confidence and building up their self-esteem. This leads to the primary challenge of the project's implementation. How can an eye-controlled wheelchair be made accessible and affordable? The solution we decided upon was simple. We would build a modification which could be designed to an existing electric wheelchair and move the joystick in accordance with the user's eye movement. To accomplish this, we used the Tobii Eye Tracker 4C to track the user's gaze based on a tablet's GUI. Meanwhile, the joystick moving mechanism was designed using the CAD software Fusion 360 and 3D printed to accommodate servo motors. For safety purposes, a front and rear ultrasonic sensor was implemented for collision detection, as well as a reverse camera for greater spatial awareness. Finally, we used an Arduino Uno to control both servo motors and the sensors, as well as performing the logic for the system. So how does it work? Let me explain. First, the user will look at an arrow on the GUI in the direction they wish to move. The GUI uses the tablet's camera when moving forward and a webcam positioned at the rear of the wheelchair when reversing, so that the user has a clear view of their surrounding environment. Additionally, as you can see in the bottom image, when the user is looking at a particular arrow, the arrow is highlighted in green to indicate the movement direction. Next, the GUI will send the required position value in degrees for each servo motor to the Arduino application. The Arduino application will then check the distance of potential objects from the wheelchair in the direction of movement. If the distance is deemed to be too close, the wheelchair will remain stationary and a collision detection alert will pop up on the screen warning the user that they are unable to move in this direction. However, if no objects are detected in a nearby range, the servo motors will move the joystick to the necessary position. Now that you have an understanding of the project and how it works, let's see it in action.